Bismillahirrahmanirrahim. The new topic, sorry, the same topic, but the new heading: hybrid parameters. Now, hybrid. What is the hybrid parameters? Before we calculate impedance parameter, we calculate admittance parameter. What does mean hybrid? Hybrid means in which the combination of both, that is admittance and impedance, are combined together, and it's a hybrid parameter. So the Z and Y parameters of the two-port networks do not exist always. So there is need for developing another set of parameters. This third set of parameters is based on making V1 and I2 the dependent variables. V1 and I2 the dependent variables, and we may write the hybrid parameters like V1 equals H11 I1 plus H12 V2. V2 equals H21 I1 plus H22 V2. So hybrid parameters, the use of hybrid parameters is well suited to transformer circuits because these parameters are among the most convenient to measure experimentally for a transistor. For example, the gain of a transfer, the gain of we want to calculate the gain of the amplifier, gain of the transformer transistor. So these parameters are helpful for calculation of the gains, for the forward current gain, reverse voltage gain, and so on. So we move as we move further, we understand well. Also, the hybrid parameters, they are very useful for describing electronic circuits such as transistors. Much easier to measure experimentally H parameters. So H11, now start writing. H11, that is the first parameter, is equals to V1 over I1 termed V2 equals 0, right? H11 from this V1 ratio I1 V2, because when this parameter is 0, we found this, right? When this parameter is 0, we found this, means H12. So H12 equals V1 over V2, that is the ratio of voltages, termed as I1 equals 0. Right? When we want to calculate this parameter termed as 0. I1 equals 0. Similarly, H21 equals V2 over I1 termed, that is, this term should be 0, that is V2 equals 0, right? And H22 equals V2, H22 equals, sorry, there is correction in the equation. Sorry, this one is not V2, but this is I2 actually. In one equation the parameter is V, in the other equation the left hand parameter, the independent variable, is I2, right? So this was a correction. So when you are going to calculate the H21 was the ratio of I2 over I1, right? Is a ratio of I2 over I1, V2 termed as 0, and H22 is the ratio of I2 over V2, I1 equals to 0. So by you see, V2 0 means short circuit. You short circuit the output terminals. I1 0 means input. You have to open circuit. Okay. Current 0 means open circuit, voltage 0 means short circuit. So the hybrid parameters are calculated in such a way, when you want to calculate the H11 parameter, you need to short circuit the output side, V2 equals to 0. When you want to calculate H12, you need to open circuit input side, that is current 0. When you want to calculate H21, you need to short circuit output side, V2 equals to 0. When you want to calculate H22, you need to open circuit input side, that is current 0. So hybrid means combination of all these. That is, two parameters come by open circuit, two parameters come by short circuit. So that's why it is called hybrid. or in hybrid you say that input voltage, this one is input voltage and this one is output current. This is input voltage because the subscript 1 means input, subscript 2 means output. So this is output current, this was is input voltage. So the parameters designated as, for example, the parameter H11, H12, H21, H22. These parameters actually H11, what does it shows? H11 shows that short circuit input impedance. Short circuit input impedance. Why impedance? Because the ratio of voltage over current is impedance. Impedance. Remember, H11 was the ratio of voltage over current, right? What is H12? The hybrid second parameter, H12. It is open circuit reverse voltage gain. Open circuit reverse voltage gain. So open circuit reverse voltage gain. What was H12? H12 was the ratio of V1 over V2, because it is a ratio of two same quantities, so it is voltage gain. It was a ratio of two same quantities. See the ratios of voltage. Why it is reverse voltage gain? Because it is a ratio of input over output, that is terminal 1 terminal 2. If it is V2 over V1, it is forward gain, right? It is reverse because it is a ratio of normally we take output over input, right? But it is input over output. See, input over output. So that's why reverse voltage gain. So H21 H21 is short circuit forward current gain. Forward current gain. H2 to H21, sorry. Forward current gain. It was a ratio of two same quantities, that is I2 over I1. See, why forward? Because second output over input, that was forward. If input over output, reverse, right? So it is forward. And why short circuit? Because in this our voltage, that is V2, was 0. Current 0 means open circuit, voltage 0 means short circuit. And finally H22, the parameter H22, open circuit output admittance. Open circuit output admittance, because it is a ratio of current over voltage. It is a ratio of current I2 over voltage V2, and output admittance because it appears at output terminals I2 V2, and open circuit because in this I1 termed as 0. I1 termed as 0. Short circuit, open circuit. So see all these parameters, that is short circuit input impedance, open circuit reverse voltage gain, short circuit forward current gain, open circuit output admittance, input impedance, output. See, hybrid, all the parameters, impedance, admittance, gains. So that's why it's hybrid. And the use of these parameters are, as I have told earlier, that in the electronic circuits like transistors. Also, we may represent these hybrid parameters in short form like H11 equals to Hi, that is impedance, and H21 short circuit input impedance, H12 reverse voltage gain, reverse, that is HR reverse voltage gain, forward current gain, that's why HF, HO, that means output admittance, input impedance, output admittance, right? Easy to remember: impedance and admittance, gain and gain, reverse gain, forward gain, right? So we may designate our parameters like this. H1 can be designated as Hi, H12 can be designated as HR, H21 is designated as HF, H22 is designated as H naught. We may summarize the parameters, that is H11 against G11. H11 was short circuit input impedance. G11 is open circuit input impedance. See, exactly reverse, short circuit, open circuit, right? H12 was open circuit reverse voltage gain. G12 is short circuit reverse current gain. This was voltage gain, reverse voltage gain. This is reverse current gain, exactly opposite, right? Or inverted, right? H21 was short circuit forward current gain. In case of hybrid parameters, short circuit forward current gain. G21 is open circuit forward voltage gain. See, this one current gain, this was short circuit, this was open circuit, this was short circuit, this was open circuit, open circuit, short circuit, open circuit. See, exactly reverse. H22 open circuit output admittance, G22 short circuit output impedance. This one is impedance Z, right? Just move the camera. Impedance. I hope this summary is helpful. And let's do an problem, an example. Find the hybrid parameters for two-port network. Two-port network is given to us, that is 2 ohms, 6 ohm, and 3 ohms. So we need to connect a current source, test current source on input terminals, that is I1, and voltage drop across that current source is V1. And this current flow is I1. This current, and we by short circuiting secondary side, that is output terminals. We short circuit output terminals, and voltage remains 0 at output terminals, and we calculate the quantities. Similarly, we open circuit input side. This is open circuit, that's why current is 0, and we connect a test voltage source on second terminals, that is output terminals V2, and current draws from that terminals is I2. Let's start solving this problem. To find the parameter H11 and H12, we short circuit the output port. See, for parameter H11 and H21, we short circuit the output port and current, and connect a current source I1. See, we connect a current source I1 to the input port, right? So what being the voltage V1? What is this voltage? So you see, this current, that is I1, this current is I1, this current flow is I1, and that I1 goes to, that is by short circuiting these terminals. Now 3 and 6 are connected in parallel, because when current comes, current divides in two paths, and both 3 ohm and 6 ohm are connected end to end like this, short circuit, I have explained earlier. So 3 and 6 ohms are in short circuit. So what is V1? V1 voltage equals current I1 times the resistance 2 plus 3 parallel to 6. Right? Current is equals to voltage into resistance. So total resistance is 2, that is series resistance, and these two parallel. So when you combine all these, you will get V1 equals 4 times I1. Just save it, this value. V1 equals 4 times I1. Right? So in this way we calculate our parameter H11. H11 parameter was the ratio of input voltage over input current, V1 over I1. So V1 is 4 times I1, and I1 is I1. I1 is cancelled with I1. So H11 comes out to be 4 ohm, because it was input impedance. Ratio of voltage over current is what? Impedance. So input impedance comes out to be 4 ohms. Now H12. For H12 we need to calculate the current. For H21, this was H1. H21 we need current I2. We need to calculate this current, that is I2. So let's move. So to calculate the parameter H21 is the ratio of output current over input current, that is I2 over I1, that is reverse current gain. So what this current is I2. See, actually the direction of current is I2, not like this, but it is the actual direction, because source is connected over here. So source gives the current. So the current I2 must be flow in opposite direction. So we designate I2 as minus I2. And how we calculate this I2 current, that is this current, we apply current division rule, right? Current division rule. That means total current. Total current is what? I1. Total current I1. Current division rule, multiply by otherwise resistance, that is 6. See, total current multiply by otherwise, the otherwise for this is 6, right? And on the denominator the sum of both the resistance, that is 6 plus of 3, right? So by using current division, here we use CDR, current division rule, and we calculate I2 in terms of I1, right? Minus sign because of direction. So H21 comes out to be, it was a ratio of I2 over I1. So when you I2 in terms of I1 is cancelled with the I1, and because it is current gain, so it is a ratio of two same quantities, so there is no unit, right? It is reverse current gain. It comes out to be minus 2 over 3, right? Now move towards this circuit. Move towards this circuit to calculate the other two parameters. The other two parameters are H12 and H22. So these parameters we can found by open circuit the input port, and connect a voltage source, that is V2, in the output port, right? So we connect output. Now comes towards H12 and H22. Now we have to calculate the parameters H12, that is the ratio of V1 over V2, forward voltage gain, and H22 is the ratio of current, that is output admittance. Current over voltage is what? Admittance. So for this, consider the circuit, that is output terminal is connected with the voltage source, input remains open circuit. So how we calculate V1? See, what is this voltage V1? This voltage is what? This voltage is same as this voltage. Why? Because there is no current, so no voltage drops, right? So this voltage is directly, that is 6 ohm voltage is appear across V1. So voltage division rule, but this voltage, actually see, the voltage, what is this voltage V2? It is the sum of these two volt, KVL, Kirchhoff voltage law. What is this voltage? This voltage drop plus this voltage drop is equals to this voltage. So total voltage is equals to this drop plus of this drop, right? So what is this voltage? That is V1. So V1 is equals to, by using voltage division rule, VDR, it is the voltage which appear across 6 ohm resistance, multiply by total voltage. Total voltage is V1. Total voltage is total voltage is V2, the source voltage, divided by sum of both, that is sum of both resistance, because this voltage, this total voltage divides among these two voltages. The voltage appear across 6 ohm is V1 actually. So 6 plus 3, voltage division rule, right? In voltage division rule we take the same resistance, right? In current division we take the otherwise resistance. So V1 becomes 6 V2 over 9. 6 V2 over 9, or 2 over 3 V2. So in this H12 equals, it was a ratio of V1 over V2. V1 in terms of V2 is 2 over 3 V2 over V2. V2 is cancelled with V2. It is comes out to be 2 over 3. H12 is equals to 2. It is a ratio of two same quantities, so there are no units, right? And it is reverse voltage gain, right? So 2 over 3 comes out to be. And what is H22? H22 is a ratio of I2 over V2. Now we need to obtain our V2, that is this voltage, in terms of I2, right? Because we have to take the ratio. So V2 in terms of I2 is what? V2 in terms of I2 is equals to this drop plus this drop is equals to, right? What is V2? V2 is this current, this drop plus this drop is equal to V2, right? This drop plus this drop is equals to V2. So V2 is equals to 3 plus 6, 9 I2, right? V2 is equals to 9 I2. And what is H22? I2 over 9 I2. So I2 is cancelled with I2. So H22 equals 1 over 9. H22 equals 1 over 9. And what is the unit of H22? Siemens, because it is a ratio of uh, sorry, H2 is the ratio of I2 or yes, it is admittance. Yes, the unit is Siemens, right? So we put S. The unit is Siemens. So that we calculate all the parameters, and we may write all the parameters in term of matrix like H11, H12, H21, H22. We may write like this. H11, you may write the values, right? So this was the solution of the problem. Now consider transmission parameters. Transmission parameters, again, same two-port network, but practically the current at other port is not entering, but it is leaving. You know, if you consider transformer, this one is primary side, this one is secondary side. The secondary side is consuming actually. The current is leaving the port, not entering. Right? Physically, it is leaving. So I2 remain wherever I2 appears. You see, wherever I2 appears, there is a negative sign because of actual current flow. So the two-port parameters show how circuit transmits voltage and current from source to a load, right? They are useful in the analysis of transmission lines such as cable, fiber, because they express sending end variables V1 and I1. They are sending end variables, sending end. This one is sending end, this one is receiving end, right? So they are sending end variables V1 and I1 in terms of receiving end variables V2 and minus I2 because original two-port network was I2 direction was reverse. It was entering the port while this one is leaving the port, so that is minus. For this reason they are called transmission parameters, and they are also known as A, B, C, D parameters. A, B, C and D, capital A, right? So they are used in the design of telephone systems, microwave networks and others, right? So what is the value of A? That is, value of A is the ratio of input voltage over output voltage. That is, it is dimensionless because ratio of two quantities, right? So there are no dimensions, though no units for this, right? So A, actually the A shows to you open circuit voltage ratio, right? See, I2 is equal 0. Current 0 means open circuit, right? So A2 in the parameter A shows to you open circuit voltage ratio. Parameter B shows to you it is a ratio of voltage over current. We know this is impedance, right? So it is, and voltage 0, so negative short circuit transfer impedance. B shows to you negative short circuit transfer impedance. What does C shows to you? C is the ratio of current over voltage, and we know the ratio of current over voltage is admittance, and current remains 0, so it is open circuit transfer admittance, right? Open circuit transfer admittance. What does D shows to you? D, again, it is a ratio of currents, like it's like A, but ratio of currents, it was ratio of voltage and it was ratio of current. So negative short circuit current ratio. See, negative, I already explained why it is negatives, right? So D, A and D are similar. A was voltage ratio, open circuit voltage ratio, and this one is short circuit current ratio. Why? Because voltage 0. So short circuit voltage ratio. D shows to you short circuit voltage ratio. So the units of A and D are dimensionless because the ratio of same quantities, but the unit of B is ohms because it is impedance, and the unit of C is Siemens because it is admittance. Since the transmission parameters provides a direct relationship between input and output variables, they are very useful in cascaded networks. What is cascaded means? The output of one is connected to the input of the other, right? So cascaded networks. So we may write our transmission parameters like V1 equals capital A V2 minus B I2, and I1 equals C V2 minus D I2. So you just, if you rearrange this, you can find this parameter. A is V1 over V2, right? B is V1 over minus I2, right? C is I1 over V2, and so on. Because I have explained these things so many times, so I don't want to repeat it again, right? So if v1 is equal to a times v2, this one is v2, right, minus b i2. I1 is equal to c times v2, this is v2, minus d times i2, right, v2 i2 v2 i2. See, v1 and v2 i2, v2 i2, this one is i1, input port, right. So transmission parameters can be write directly. I hope you understand. The last topic of this chapter, interconnection of the networks. Interconnection of networks means a large complex network may be divided into sub-networks for the process of analysis and design. The sub-networks are modeled as two-port networks interconnected to form the original network, right? For example, this cascaded network, for the transistor of the output of this transistor is connected to the input of another transistor, right? So interconnected networks means so many networks are connected. The two-port networks may therefore be regarded as building blocks and that can be interconnected to form a complex network. The interconnection can be in series, in parallel, or in cascaded, right? Although the interconnected network can be described by any of the six parameter sets, a certain of parameters may have a definite advantage. For example, when the networks are in series, their individual z parameters add up to give the z parameters, right? It is the same that when you add up the series resistance, what happens? The series resistance add up and it becomes large, right? For example, R1, R2, R3, R4 are connected in series, and what is the equivalent? The equivalent is the sum of all. So they are added up actually. When they are in parallel, when the networks are in parallel, their individual y parameters add up to give the v parameter, right? When the networks are in parallel, their admittance parameter y is add up actually, because y is opposite to z. So y is treated parallel like series in impedance, right, and vice versa. So y parameters are larger in networks when they are connected in parallel. When they are cascaded, their individual transmission parameters can be multiplied together to get the transmission parameters out of larger network, right? When they are cascaded, what happens actually? The ratio or the gain is multiplied actually, multiplied, and it is give a higher ratio, a higher gain, right? So this is ends up circuit analysis course from my side, and I have completed all these chapters, that is polyphase circuits, then magnetically coupled circuits, and finally two port networks. I hope you understand this subject very well, and you must practice it for to be grip on this subject. I have told you so many times that please make your lecture copy so that you can grip the subject and you can understand the subject very well. And I wish you all of best of luck, and thank you.